Hi, we're back with lesson 4.2, and this is video 2. We're still talking about rate of change, but this time we're talking about rate of change from graphs. So let's go ahead and get started here. So in this algebra unit that we have here, we're going to focus on 3 specific types of graph. One is a linear function, the other 2 are exponential and quadratic. You were introduced briefly to these in the first unit when we were talking about graphing them. But linear, of course, here is a straight line. The exponential has this like little slide, this curve right here in here. And a quadratic has this U shape. Linears have a constant rate of change. That means no matter where I'm looking at on this graph, I can pick any 2 points on the graph. And the rise and the run are the same. So the rise is 2 and the run is 2. So the slope is 1 over 2. Or I can pick somewhere else on there if I went to another place on that line. So for example, from here to here. The rise on this one is 4 and the run is 8. And so if I took that, that would be 4 over 8, which is still 1/2. So the slope of this line, or the rate of change of this line, is the same no matter where I'm looking at on the line. If I go over and look at an exponential, you can see in some places it's a whole lot steeper than it is in other places. Here it's very steep, here it's not steep at all. And so this is said to have a variable rate of change. Looking at this quadratic right here, here I'm going downhill and it begins to slow down almost like a roller coaster, and then I start going uphill again. So one of these has a negative rate of change, the other side has a positive rate of change. So linears have what are called constant rates of change. That means no matter where I'm looking at on the graph, the rate of change is exactly the same. But an exponential and a quadratic have variable rates of change. That means it'll appear steeper in some places than it does others. Well, with a linear, it's not too important about where I'm talking about on the graph, because no matter where I'm talking about, the rate of change is the same. But for an exponential and a quadratic, I have to tell the interval over which I'm talking about. So the part of the line I'm talking about, that's what I mean when I say interval. So let's go back and just review. If you have 2 points on a line, how do you find your slope or your rate of change? What's the change in the y's over the change in the x's? So let's pick at 2 points on a line. On my linear one, here are 2 points. Let's say the point right there, 4, -1. And let's pick another point, and that point would be 6, 0. So if we're going to find the rate of change in between those, we take the y values and we subtract them. So we have 0 minus a -1. And then we take our x values and subtract those. So we would have 6 minus a -4. And of course, we would have to change our signs where it has minus a negative, and our slope would be 1/2. We already knew that because we counted our rise and our run. Now, if you're going to do it that way by counting your rise and your run, be very careful that you look at the scale that your graph is counting by, because if it were counting by 5s, then these numbers would be different, and you have to be very careful there. So you might find it very useful to always just choose 2 points that are on the line. So let's go over here to our exponential. We're going to find an interval, and we can choose any interval we want. We're going to go from where x is equal to 0, which is here, to where x is equal to, let's say right there, where x is equal to 2. Okay, now those are not, we're going to use interval notation. That looks like this, 0 to 2. So what that means is x is equal to 2 to where x is equal to 0 to where x is equal to 2. That is not the ordered pair. That is not the point that I'm talking about right here. So when I go to talk about the point, then it would be oh, dear me. Let me go back here. That would be the point. Let me pick up my pen. That would be the point 0, 2 to the point 2, 7. So when we go to subtract those, that would be 7 minus 2 over 2 minus 0. And so that would be 5 over 2. And again, you could do the rise over the run. If you did that, you would rise 5, 1, 2, 3, 4, 5, and you would run 2. Rising 5, running 2. But again, I will caution you, if you do that, you want to make sure you're paying close attention to what your scale is. So now let's come over to the quadratic. Let's find an interval that we want to talk about on this one. Let's go from where x is equal to 0, which is right there, to say where x is equal to maybe 3 right here. Okay, so from the x equal to 0 to where x is equal to 3. That means x is equal to 0 to x is equal to 3. So let's find our ordered pair. That is the ordered pair 0, negative 3. And this is the ordered pair 3, 1. So subtract your y's, 1 minus a negative 3, over your x's, 3 minus 0. So when we look at that, change your signs, change it to plus a positive. So we would have 4 over 3. So we could do our rise, we could count it 1, 2, 3, 4 over 3. So it's 4 over 3. That's the slope of that line. Now, let's go to the next one. I think we have 2 for you to try. Don't forget right here, you're going to determine the slope of this line. And over here, this is the interval x is equal to 1 to x is equal to 2. So don't forget that as you're looking through there. That is not a point. Okay, so go ahead, pause and try your U-try.